Hello, this is a lecture on calculus, and this is the first lecture. We start with describing what a function is. We talk about function. Let's have an example. I have a relation y equals 2000 plus 25x. If x is 1, then y is 2025, right? For x equals 1, so y is equal to 2025. If x is 2, then 2 times 25 is 50. So y is 2050. If x is 3, you can find the corresponding y value. So you can have y value. You can find y. And you can carry on. In other words, for every x value, I have a y value. Then we say y is a function of x. So the label for y is a function of x is this way. Y is a function of x. This writing means y is a function of x. We understand that if x has a value, then by calculation you can get a corresponding value of y. So y is a function of x. We call x an independent variable, and we call y the dependent variable. Let's have another example. Months. And the sales. So, for example, I have there is a store. The store sells toys. So in the first month, the store sells 40 toys. In the second month, the store sells 60 toys. And you can list it. The third month, the fourth month, and so on until the 12th month. And for each month, you have a quantity of sales, and you fill in the table like that. So in this case, this is the independent variable. This is the dependent variable. So you can, for any independent variable, say 6, and you can find how many sales. So from the table, the sales is a function of the month. So the sales is a function of the month. I can have another example. The first example, let's go back. The first example here is a given relation. The second example is given in the form of a table. I can have a third kind of example, which is a graph. So suppose I have this. This is the time of the day. Say this is midnight, 0, and 1 o'clock after midnight, 2 o'clock after midnight, and so on until 24 hours after midnight. That means the second midnight. So from midnight to midnight, I record the temperature. So this is temperature. The temperature of the day at various times. So for example, the temperature at midnight is this, and the temperature goes on when it approaches the noon time. So the temperature goes higher when it is noon, and then in the afternoon it cools down, and when the second midnight comes, it cools down. So this is the change in temperature at various time of the day. So this is a graph. So we can also say the temperature is a function of the time, because at every time, say 2 o'clock after midnight, you can have the temperature. You can have this temperature. Given the time of the day, and you can find the temperature from the graph. So the temperature is a function of the time of day. Okay. So next, we want to introduce some terms. The term is called domain. Domain. Domain refers to the independent variable. Independent variable. Usually we refer to x. Usually we use x to represent the independent variable. Now, to understand the meaning of domain, let's have an example. Y equals 2x square root 2x minus 3. If you give x a number, you can find the value of y. For example, suppose x is 2. 2 times 2 is 4. 4 minus 3 is 1. The square root 1 is 1. So, when x is 2, y is 1. You give x another value. If x is 3, then 2 times 3 is 6. 6 minus 3 is 3. Therefore, y is square root 3. So, for x value given, we can find y. So y is a function of x. But suppose you give x the value 1. So 1 times 2 is 2. 2 minus 3 is negative 1. The square root of negative 1, I don't know what that is. I cannot do it. So negative 1 doesn't work. That tells you x cannot be any value. X can only be certain values. Now, these values which can give you y is called a domain. So the domain is only if 2x minus 3 is positive. It's larger than 0. If this is positive, I can take square root. How about 0? The inside is 0. 0 is still okay because square root 0 is also 0. So, this condition must be satisfied in order to find the y value. Let's solve for this. 2x minus 3 is larger or equal to 0, so which means 2x is larger or equal to 3. Therefore, x is larger or equal to 3 over 2. Do you follow the calculation? I did my calculation mentally. Okay. Do you follow? 2x minus 3 is larger than or equal to 0. You move the negative 3 to this side and divide by 2, you get the answer. This answer is called domain. Domain gives you a condition. If this condition is satisfied, you can find y. Okay. Let's have another example. Y is equal to x plus 1 numerator. Denominator is 3x minus 2. Then this example, again, we want to find the domain. Okay, let's use D to represent domain. Domain is what? This is a fraction. We know that you cannot divide by 0. anything divided by 0, you don't know what that is. It's undefined. Therefore, there is a condition that the denominator cannot equal to 0. So this condition must be satisfied in order to calculate y. So the condition is 3x minus 2 cannot equal to 0. So let's write down the condition. 3x minus 2 cannot equal to 0. You move the negative 2 to the right hand side. 3x cannot equal to 2. And divide by 3 on both sides. Then x cannot equal to 2 over 3. So this is x cannot equal to 2 over 3. But x can be other values other than 2 over 3. It's all right. Huh? Only this value is not allowed. So the domain is x is any value except 2 over 3. Understand? Domain is any value except 2 over 3. Okay. Let's have another example. Now this is a log function. Y equals log 5 minus 2x with the base 3. Do you know the graph of a log function? To answer this domain, what is the domain of this? To answer this, you must know how a log function looks like graphically. And let's draw a general shape of a log function. The general shape is something like that. In other words, the log function has a restriction that the independent variable here, the x-axis, the value of the x-axis cannot be less than 0, including 0. In other words, the restriction is it's only larger than 0, not equal to 0, larger than 0. So this part must be larger than 0. This value, the value on the x-axis is larger than 0. Now I have a bracket. Then this restriction means this part must be larger than 0. It cannot equal to 0 because when this part is equal to 0, the log gives you negative infinity, which is undefined. So the restriction is the condition for y to exist is 5 minus 2x is larger than 0, which means x. Can you do this mentally? Look, negative 2x, I move it to the right hand side. Therefore, 2x is here, which means 2x is less than 5. 2x is less than 5, which means x is less than 5 over 2. And this is my domain. This is my domain. Do you follow? Yeah, this is my domain. Now, the next example. I can have a sum of two terms for the y. Suppose y is equal to, this plus the log function. Suppose y is that. Okay, so let's write. Suppose y is a square root function plus my log function Suppose y is a sum of these two terms. What is the domain? Okay, this is our example we did. This is just a last example. So this example tells the restriction, the domain is x is larger than or equal to 3 over 2. Now this is a result of this example. We did this already. We have this example already. And this example is just the last example. And the domain of this is x is less than 5 over 2. Then what is the domain of the whole function? What is the domain of the right-hand side? Then the domain must be this and this combined. X is larger than this. X is also smaller than this. We can write this on one line. So x is larger than 3 over 2. Larger than or equal to. Here, you read x is larger than Do you follow this writing? X is larger than or equal to 3 over 2. At the same time, x is less than 5 over 2. So we can write this way, and this way is just you combine this domain and this domain. You write them together. So this is how you write it. So this is about domain. Next, we will talk about two terms, odd and even. Odd and even. Odd and even. What is an odd function? What is an even function? So we want to discuss that. To discuss that, it is best to do some example. So let's look at this example. Y equals x cubed. So we ask the question, is this an even function or an odd function? The best way is to graph it. Of course, we have a mathematical definition of odd and even. But the best way, I stress the word best. The best way is to have a graph. Do you know how this graph looks like? To graph this, you can do a table values. You let x equals -3, -2, -1, 0, 1, 2, 3, and so on and so forth. And you do a table, and from the table, you can graph it. And if you do that, the result is this. This graph is the graph of this function. We say this is an odd function. Now we discuss what does odd means. Odd means, graphically, means if you reflect this in the y-axis, if you reflect this part in the y-axis, you get this, right? After that, you do another reflection in the x-axis. So you reflect this in x-axis, then this goes down. So this part is two reflections of this part. First, you reflect this in y-axis, you get this, and you reflect this result in x-axis, you get this, and this is how the graph look like. So two reflections, and you call this odd function. How about mathematically the definitions of odd function? Mathematically is this. You replace x by -x. Okay. I replace x by -x. So replace this x by -x. And this power means you multiply itself 3 times. So I have, now you replace x by -x, and then we do the power 3 times. So it's -x times -x times -x. You have 3 negatives, negative, negative, negative. So the result is negative. Negative times negative is positive. Positive times another negative is negative. And then you do x times x times x. It's this, right? You compare this result with this result. Compare that. You see, this is equal to the negative of the original y. The negative of the original y. Now, this is the definition of odd function. If you replace x by -x, and the result is the negative of the original y, then it is called odd. You get it? Let me repeat. Mathematically, if you replace x by -x, and you carry on the calculation, if the final result is the negative of the original y, then the original function is called odd function. Now the even function is very easy to understand. If you replace x by negative x and work it out, and the result is exactly the original y, then it is called an even function. Let's make a summary. If you replace x by negative x, and the result is the negative of the original y, then it's called odd function. If you replace x by negative x, and the y doesn't change, it is still the same as the original y, then it is called an even function. Graphically, how does an even function look? Graphically, the even function is, so this example is an even function. This is an even function. Because if you replace x by negative x, and the power is 2, so this is negative x times negative x. So negative times negative is positive, this is positive, and x times x is x squared. But this is exactly the original y. So this is exactly equals original y. You replace x by negative x, and the result is exactly the original y. This is called even function. How does the graph look like? The graph is y equals x squared. Y equals x squared is this. It's a parabola. Now you see, if you reflect this in y-axis, you get this. So the even function is that the right-hand graph, this graph, if you reflect it in y-axis, and the result is the entire graph, then it's called even function. So that is the meaning of odd function and even function. So next we need some examples, more examples about even and odd. I'd like to stop now. We will continue in the next lesson. I don't want my lesson to be too long, so we already have 30 minutes for the first lesson. So let's stop here, and we will continue next time. Goodbye.